Hi, this video will talk about piecewise functions, and there's three things that we want to do with piecewise functions. The first one is to evaluate them, okay? Notice I have f of x here, and this is just like evaluating any other function when I put f of -1. I want to know what my function is equal to when x equals -1. So the way that piecewise functions work is that they're defined in pieces. Here's piece 1, and here's piece 2, and here's piece 3. This piece, the first piece, only works when x is from -3 to 2. So when x is from -3 to 2, I'm going to evaluate the function using this first piece. The second piece works when x is between 2 and 4. So if x is equal to 2, and equal to 4 or anywhere in between, I would evaluate the function using this second piece. The third piece works when x is between 4 and 8. All right. So now let's think about that. If I'm asked to evaluate f of -1, that's the same thing as saying x equals -1. The -1 tells me that I'm going to use this first piece right here. How do I know that? Well, -1 falls in this range. It's greater than -3 and less than 2. But I'm still not done. I have to plug in -1. Well, in the first piece, our function's equal to a constant. So there is no plugging in. So f of -1 is equal to 3. All right? So basically, we have a few steps. First, we have to decide which piece of the function we're going to use. And then if there's an x, we have to plug this value in for x, such as in the second case, f of 2. In this case, I see I have a 2 here and a 2 here. But this is the same thing as saying x equals 2. My equal sign corresponds to the second piece here, okay? Here's the equal sign. 2 equals x, okay? So I'm going to use the second piece of the function. And I would actually, the next step is to plug it in. So I'm going to use x minus 2, all right? But I know one more piece of information. I actually know what x is, so I can say 2 minus 2. All I did was plug in my 2 for x, and I know that that is equal to 0. So when I evaluate this function at x equals 2, it's equal to 0. Let's do one more, f of 7. We're going to use the 7 to tell us which piece to use, the first piece, the second piece, or the third piece. Well, I see that 7 falls between 4 and 8, so I'm going to use the third piece here. So I know that it's equal to 2x. But I'm still not done. I need to plug this 7 in for x. So I see that it's equal to 2 times 7, or 14. So just to review, we use what's in parentheses to determine which piece of the function we're going to use. Once we decide which piece of the function we're going to use, we have to make sure that if there's an x in there, we plug that value in for x and continue to evaluate the function. All right, the second thing you're going to be asked to do with piecewise function is to determine the domain. When I say domain, you should be thinking x values, okay? So for what x values is this piecewise function defined? This is really quite easy. You're going to look here and pick out the smallest value of x for which this is defined here. So it's -3. -3 less than or equal to x. And what's the largest value for which x is defined? Well, I see it's here, 8, less than 8. And I can also write that in interval notation, -3, 8. Okay, actually I need a square bracket here because there's an equal sign. All right. Now the final thing you're going to be asked to do is it continuous? The best definition of continuous is if I draw the function, all right, and trace it with my pencil. If I have to pick up my pencil, so do you pick up your pencil to trace it? If the answer is yes, then it is not continuous. Okay, that means that there's a gap somewhere. If the answer is no, if you don't have to pick up your pencil, then it is continuous. A straight line is a good example of a continuous function, okay? Suppose I drew a straight line on here, okay, in orange, and now I ask you to trace it. You come back in, all right, and you trace this line, but notice I can trace it, all right, without picking up my pencil. I can follow the whole line without picking up my pencil, okay? So let's actually graph our piecewise function and see if it's continuous. All right, so here I have the graph. The way you're going to do this is you want to graph the first side. So from -3, x equals -3 to 2, this function's equal to 3. All right, so -3 minus 1 minus 2 minus 3. It's equal to 2. There's a solid line there. And all the way to x equals 2, this function's equal to 3. So it's going to be this line here. From 2 to 4, my function's equal to x minus 2. Okay, so x minus 2. So on this one, I'm going to have to actually look at some values. If I plug in 2, my y would be 0. If I plugged in 4, my y would be 2. So at 2, it's 0. And at 4, all right, it's 2. Okay, so here's the second piece of this function. And finally, if we look at the third, 2x, I can plug in some values here. At 4, it's 8. And at 8, it is 16, okay? So at 4, it's 8. 5, 6, 7, 8. All right. And it's going to be like this because the next one, so it's going to go this way off the page, okay? Now the purpose of graphing it is to determine if it's continuous. So now if you come back in here and you trace this function, do you have to pick up your pencil? All right, so when you trace this function, do you have to pick up your pencil? Well, let's start at the lowest number at -3. So let's trace. Trace, 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 trace. Here at x equals 2, in order to continue to trace, I have to pick up my pencil and jump down here to y equals 0. Then I can trace, trace, trace. And now to finish my tracing, I have to pick up my pencil and move up here and trace, 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 trace. So the fact that I had to pick up my pencil, this should actually be an open circle, means that it is not continuous. If you graph it and you can trace it without picking up your pencil, then your function is continuous. I hope that this explains piecewise functions.